Hello and welcome back to Higher Maths, Logarithms and Exponentials. Lesson 5, Exponentials and Logarithms to the base e. So, as we've seen earlier, the constant e is a very special number in mathematics. Its value to 9 decimal places is 2.718281828. But remember from before, you can find that in the calculator. Just a reminder where it is, guys. Grab my calculator there. So shift ln. So there we have e to the power whatever we want to raise it to. Okay. So express in exponential form, y equals log to the base e of 6. So quick flick back to the top of page 6 where we're moving between exponential and log form, going back and forward. So x equals a to the y, so just matching up with what we've got there, we would have e to the power y equals 6. Number 2, express in log form, y equals e to the 7. So again, just matching back up to page 6 there, log to the base e of y equals 7. Now, log to the base e in maths is very, very significant and important. It actually has its own notation. Ln of y means log to the base e of y. So on our calculator, we do actually have a log to the base e button. There it is there, ln. So that's log to the base e. I think it's from the French, logarithm naturel, although I'm not 100% sure on that, so I should really go and check that up if I'm saying it on a video. Question number 3, calculate the value of log to the base e of 6. So for that one, I would just use the ln button, the natural logarithm button on my calculator. So ln 6, 1.79175, etc. So rounded to 2 decimal places, that would be 1.79. Solve log to the base e of x equals 9. So moving from log format into exponential format, x will be e to the power 9. So again, just type that in. There we go, 8103.083. Generally speaking, if I get an answer like that, higher maths, I'll be slightly suspicious of it, but that is the correct answer. Normally, we just don't seem to get many answers in the thousands. So always have a look at your answer and just think, does that look sensible? Does that look like an answer I would normally get? But in this case, we are doing basically 2.718 raised to the power 9, which will be quite a large number. Question number 5. So this is an old exam question, it's reasonably tricky. Simplify, so all to the base e, so 4 log 2e minus 3 log 3e, expressing your answers in the form of a plus log b minus log c, where a, b and c are whole numbers. So would I expect you guys to be able to do this straight away? No, I wouldn't. This is a question you'll be building up to by doing all of the bookwork exercise. So we'll go through it. But quite often in higher maths, it's not a case of looking at a question and thinking, how do I do it? And just being able to see every single step in your mind before attempting it. Sometimes we do need to take a leap of faith. We need to basically have a go at something. And if we get it wrong, we'll rub it out, try it again. But in this question, what can I actually do? Well, 4 log 2e minus 3 log e, we might be thinking, well, I want to add these together or subtract them. So can I use rule 2? At the moment I can't because it doesn't say log minus log. If it said log of bracket minus log of the other bracket, then I could just subtract using log law 2. But I can't do that yet. So what I'll need to do is use log law 3 and bring my 4 and my 3 up to make those powers. So I've got log to the base e of everything to the power 4 minus log to the base e of everything in this bracket to the power 3. So we are going to get 2 to the power 4, which is 16, and e to the 4. So log to base e of that minus log to the base e of 3 cubed, 27, multiplied by e cubed. Okay. Now my final answer, I've got a plus log b minus log c, so I just need a constant term, I need a number term on its own, and it's going to be a whole number. So I'm looking at this thinking, well, I've got some 16s and 27s and some e's. So what can I do here? I can use rule 1 in reverse. So I'm going to split this up. Again, this guesswork, if you like, well, it's not really guesswork because I know how to do it, but this just comes from me doing lots and lots and lots of practice and just developing an understanding of how it works, guys. So kind of using the sort of language of the classroom, I would say I'm secure in my knowledge of logarithms, which gives me the knowledge to kind of make the right steps. Again, you guys build up to this, so if you're kind of looking at this thinking, I'm not sure I'll be able to get from this line to this line, at this point in your learning journey, I wouldn't expect you to be able to do that. Okay, some of you would, but maybe not everybody. So I can split this up into log 16 plus log of e to the 4 minus, so I need to subtract all of this. So I'm subtracting the log of 27, I'm also subtracting the log of e cubed. Okay, if we want to, we could think of that as subtract whatever this is, so that would be subtract log of that plus log e cubed. So I'm subtracting the whole bracket, so that'll be minus and that'll be minus. Now I've got e to the 4 here, so I can make that 4 log e of e. I can make this 3 log e of e. So log e of e is just 1. So here I've got 4 minus 3, which is just 1. I've got log of 16 minus log of 27. Is that in the format we're asked for? Yes, it is. I've got whole number each time, so b is 16, c is 27, and a is 1. Okay, so have a go at questions 1 to 5 on page 11 from exercise 1D. Again, a reminder, guys, I have written solutions, madrasmaths.com, staff, Mr. Young, and then the middle column has got the solutions. The right-hand column has just the answers that should be in the back of the textbook, but they're not. And the left-hand column just has a copy of these notes.